She currently is one of the people who write it and can edit it or like over,
Yeah.
I mean, I didn't finish section D, the last one about Jay Perini, which I honestly thought was community for the last.
All right, guys.
But,
So, number one, a few of you guys have lived this experience possibly, or know people that have. The comma and the decimal in certain countries are switched. I think I told you guys, and I keep forgetting to look this up, but there's an entirely different division algorithm that's used in like Russia and so forth. And so every time I'd have a student that was like that had come from the country, I had to get them to remind me, because it was like every fourth semester I'd have another student and I'd be doing something like, I've never seen that. I'm, holy shit. So they'd show me how the Russian algorithm works. It's completely different from what we do. So I'd have to look it up again. I forget what it looks like. So decimal and comma were just, they had to make a choice about what to use. And somewhere back in time, different countries chose different things, right? So this is really difficult. Can you imagine having a student who just moved to this country, they've seen their parents doing stuff, and they've learned some numbers from their parents, and they come into your class, and all of a sudden, you know, it's wrong. It doesn't mean that. That's going to be a really difficult transition. I mean, looking at that 3,14, did that make any sense when you looked at it?
Yes.
Some of you guys maybe.
Yeah.
But like, it would make sense if it was 3,147. Then we would read that as 3,147. But 3,14, like, what the hell is that? Correct? So if you move to a country that used a comma instead of a decimal, well, holy shit, right? That would take a lot of time to get used to. Yes? Okay, maybe. And unfortunately, hopefully you would fill out your check correctly, or else, oh shit. Right. So number one's pretty straightforward. It's different in different countries. Hopefully, now it's really funny. You're obviously not in that situation. So if you're going to be like, it's just not the way we do it here, you know, I would think that you wouldn't actually say that. But if I was doing this, I might just write it down. I'd just tell the kid, get used to it, sit back down. So obviously, if you did hit that situation, you might say, I'm going to work with you a little extra. I'm going to give you some more practice. I'm going to, you know, no, screw that. Just get up to speed. What do I want me to do? Sit down. All right. Now, everybody's favorite problem.
No, it's like the pine cone, not the pine cone,
All right.
the fence one from the triangle.
Now listen, can you set up fractional parts if you don't know the whole, right?
No.
So if I told you I have a bag and in it I have some marbles and 7 of them are white.
You have to add them up. Oh, probability.
It could be, fractions could be, probability is based off of percentages, which comes from fractions, ratios of parts out of whole, but you don't even have to think of it as probability. It's just what fraction of the marbles are white. So, what if I have this? I have a bag of marbles. All right? Marbles. Just thousands of marbles. And we pull out, and they're white and blue. And I pull out like 5.
White and teal.
I pull out 5 marbles, and 2 of them are white. That's how much I pulled out so far. So what fractional part of the marbles I've pulled out so far are white?
2 over x.
What fractional part of the marbles I've pulled out so far?
Oh, 2 out of 5.
2 out of 5. Does that fraction have a damn thing to do with how many of the total? No. So what if I pull out, what if I pull out, so this is the first,
Yes.
and then I pull out 3 more, right? Yeah. 3 more marbles. And one of them is white. So what fractional part of the second group of marbles that I picked out are white?
3 over 8.
What fractional part of the second group of marbles that I pulled out are white? 1 out of 3. Are these 2 things based on the same amount? Are they based on the same group? No. I really want this. I know this is difficult. This is one of my favorite, and you know me. I'm that jackass that just loves those freaky ass problems. But I want are you guys with me so far? Do you understand the basic? What's up? No? What happened? I'm with you. Do you?
I think I'm like overthinking it too hard, where like
I understand.
I'm trying to like know like the rules of baseball, and in my head I'm thinking like,
I'm sorry.
how many are in a game?
I should have rewrote it to not be baseball.
I'm like, how many
No,
games are in a
it's just
doubleheader?
marbles.
Is it actually 2? Is there like 9 games? Because there's like 9
Innings.
innings.
Yeah, it's just 2 games.
Serena.
Yeah,
Literally
so you
saying
could
that.
replace those. I was telling other people that it was 2, like 1 spicy food out of 3 that you had for breakfast.
Well, that's
right?
nice. You gave us shapes.
What's up? And then I was trying to give you shapes. Sure. What's the matter?
The spicy food would have worked better. I think it was
I'm
just baseball
sorry.
throwing me
I'm
off.
sorry.
Okay, never mind.
All right.
Never mind. Keep going. I'm
All
gonna try.
Okay, listen. So, adding these together makes no sense because they're both based on different groups. They're not based on the same thing. So, listen. How many total marbles have I pulled out so far?
8.
8. Out of those, how many are white?
3.
3. So this doesn't mean that 2/5 plus 1/3 is 3. It doesn't mean that because this isn't 2/5 of the bag plus 1/3 of the bag, is it? You guys with me? They're not both referencing the same total thing. It's 2/5 of the first group and 1/3 of the second group. There's no reason they're supposed to come together to represent anything. Now listen. So let's write this better.
I'm tired.
All right. I picked 2 white marbles out of the first pick, right? So how do I say this? I picked 8 total marbles, correct? And how many of them were white in my first pick?
2.
2 out of 8, right?
I mean, both picks.
So I ended up with 3 white marbles. And I picked 8 total marbles. 2 out of 8 of those total marbles were white from my first pick.
You mean both picks?
No, just for the first.
First pick, I got 2 white marbles, correct?
How did you get out of 8? You added 3 and 5, right?
I picked 8 total marbles. 2 out of those were white from my first pick. Okay.
That makes more sense.
I picked 8 total marbles. How many out of those were white in my second pick? 1. Now they are both based on the same group. Yes?
Yes.
Now addition makes sense because now they're referencing the same thing. So listen, if I took 10% of your money and I took 10% of my money, the amount of money I have in the bank, yes? I don't know, this seems weird. I'm older, so I obviously have more money. I'm not trying to say it. If I took 10% of Jeff Bezos' money and 10% of my money, right, let's just keep it to the 2 Jeffs here. Oh, that's the only relationship I want to have. He was my really generous uncle. So if I take 10% of his money, 10% of my money, is that like an equal amount, 10% of each of ours? And I know we haven't talked about percentages. Aren't they based on 2 different denominators? Based on 2 different amounts? Yes. So I can't like put them together and it has some meaning. All right, maybe.
Yes.
I didn't think that would be, okay, this is definitely interesting. I didn't want it to be something you would want to revolt against. Okay, we'll let that one go. So the big thing there is I really want this to make, listen. Let's say you wanted to make, let me come back to my picture. I'm not going to give up on it. Does this picture represent 2/5 triangles?
Yes.
Yes.
What if you want, wait a minute, I wanted to make 3/8. I didn't want to make 2/5. I want to make 3/8. Wouldn't I add 1 more triangle? Right? 1 more triangle.
Yeah.
A bunch of other circles.
And then just 2 more circles, yes?
Yeah.
Yeah.
I think 2, yeah, okay.
Yeah.
So now I got 8 total parts, and 3 of them are triangles, yes? That does not mean that 2/5 plus 1/3 is 3/8. That's not what that means, because I can't combine fractions that are based on 2 different groups of things. I can't do that, right? Let me say this better than percentages. 1/5 of Jeff Bezos' money plus 1/5 of my money, does that equal 2/5 of something? No. Yes, because they're both based on different totals. Okay, maybe.
Oh.
See, I get
Jeff
it like in
Bezos
that
has a lot more
concept,
money.
I don't get it in like this baseball concept, so I'm gonna hold on to this, but not this. Is
The
that-
baseball is just like the marbles, and the baseball doesn't matter.
Confusing.
If
Okay.
the baseball's getting in the
I
way,
like sports.
and the other one that is the
That
same,
makes sense.
they're both equivalent, so whichever one
I don't
makes more
understand
sense.
baseball. I
That's
don't
all that
understand
matters.
sports.
Alright,
I don't understand sports.
alright guys, good. So I'm
Doesn't
sorry.
matter, so it doesn't make
Sorry,
sense.
I didn't mean to say, look on the back for all the rules of baseball, continue
I
to.
was thinking it like, you were saying like, not the, like the total parts, like the unknown of whatever, so I'm like, okay, am I not knowing like how many?
Oh, I see what you
That's
mean.
what I thought it
But-
was.
That's why I asked how
listen,
many
listen.
things are in this thing.
After the first game, you still have no idea what the denominator is going to be.
What are
Okay,
at
That's what I mean.
Okay, there you
Yeah,
go, yes,
okay.
thank you.
Say again?
At back, like at a back cave?
When it gets up to the back. Yeah, not at the back game. Yeah, there's no, they don't turn the spotlight on to call Batman every time they ever beat him. Yeah. Alright, what about number 3?
That's a little easier.
Was 3 better?
Yes.
Who can tell me concisely what the student's mistake was in part A?
Wrong decimal place value, wrong place value.
Okay, good, I like that. Yes?
They're confusing their place values, with like whole number place values.
How do you
That's
mean?
B.
Yeah.
Oh, okay.
Yeah, I think that's B. Yeah, in part A, for us, if I'm gonna write, if I'm gonna do, what do you got, Jeff? 3 over 100,000. How do you figure out where to put the 3?
Depends on the place.
Well, it's 3 over 100,000. How do you figure out where to put the 3?
Like, so we tenths, hundreds.
Yeah, so then you count it off to yourself.
thousands,
Tenths, hundredths, thousandths, 10,000ths, and then you put the 3, right?
Yeah.
So now watch, this kid does this, and he thinks that the 3 is supposed to be the same place as that 3. He puts the first digit in that place. You're supposed to have the last digit be here. Yes, so the right answer here would be tenths, hundreds, thousands, 10,000. So tenths, hundreds, thousands, 10,000s, 100,000s. That's correct. And what he did, he thinks the first number is supposed to be in this place. Maybe? Yes? Maybe? Are you guys with me?
Yes.
Yes? Maybe? No? Okay. Because again, like what? How do you say this? What is this?
79.0079.
I love it. I'm like, please somebody say that. Now, can you read it as a fraction?
79. 10,000.
Yes. Tenths, hundredths, thousandths, 10,000ths.
So 79, 10,000.
So the last digit tells you what place the whole thing is in. Are you guys with me?
Yes.
And real quick about that, people are giving me an interesting look, because this is an easy thing to kind of mix up. Do you guys agree with me that this plus this is that?
Yes.
Okay.
Yes.
What is this?
70.
7 over tenths, hundredths, thousandths. And what is this?
9 over
Tenths,
10,000.
hundreds, thousands, 10,000ths. Are these like terms? Are these like? Can I add those? No.
Not yet.
How do I make this?
0.
There we go. So this has to show up in this place. It is what designates the place of the whole thing. Does that make sense? Okay. This is a really weird little side note, but dude, when you're first learning this shit, you're gonna see students making this mistake because they're just not used to, huh?
We're teaching this.
Yes, when you're teaching this and you have students, what did I say?
When you're learning this and
Oh, I was saying from the context of the students you're gonna have. When your students are learning this, right, then they're gonna be making this kind of mistake real easy because you're just not used to thinking in this direction at all, right, with all the zeros in front and what they really mean. It's much easier the other side. Okay. What about part B? I think we basically just answered the question. Right.
And equals period. That's what I put.
Yes. So when it's a whole number, we can say 521, right? And I said the and really quickly, the 521. We could say that. And I remember always people trying to correct me. And the reason that they were trying to correct me is because the and becomes very important when you go to decimals. So I can't say this is 0.521 or something, even that's really bad. But the and means the decimal. I love it. And again, if you've ever written a check, you know exactly what I'm talking about.
So we know.
I haven't written checks, but I
I understand. Man, today I've just gotten so many times where I'm like, yes, I know I'm old. Okay. Yeah, that's it for that. Okay, good. All right, guys. Kind of rearrange yourselves back. And you guys can keep that paper. I was just joking. I just wanted you to write it nice for yourself for the future.
The second part of it.
Because we're going to have questions sort of like this on the
Yeah.
test.
I don't think we're done.
Hey, but don't do baseball.
What's up? Yeah. I'm not going to make it baseball.
Please don't. Do spicy food or something.
I could do spicy food.
Or.
I'll make it football. How's that?
Okay.
I'll make it Calvin ball. I'll make it, anybody know Calvin ball now? Oh, that's fine. I'll make it Quidditch.
Lacrosse is not a sport.
No Quidditch? Alright guys, alright. Real quick, just a couple of quick things. Somebody just said something crazy. I don't know what.
That happens a lot.
Yeah. I'll give you a second. Done. Okay. I could make up anything, but okay. Yeah. All right. We're going to do this in a way that you probably never would. But again, we're always thinking about, we're presenting this kind of stuff to people that don't do this yet, right? Little people that haven't had to do this. So we're going to make connections between fractions and decimals as we learn decimals, right? Because at this point, I'm not going to say they completely understand fractions, but they've done fractions. They've seen fractions. So can you write each of these as an improper fraction? And the funny thing is,
Would I have to start as a I would have to start as a mixed fraction, right? Or
not necessarily. I really want you
But I
guys
don't have
used to
to.
this. What would that be?
0.29.
No. Fraction.
29.
29 over 100.
That's making sense.
All right, that's 1129 over 100.
Yeah, got it.
Oh, okay, that makes sense.
Again, doesn't the last thing tell me what place I'm in? No matter what the shit, it has to be. No matter what's going on, that's what it is. And again, what is 1100 divided by 100? Here, on the side. Isn't it this? Yes? Isn't that this? What's 1100 divided by 100? Kill the zeros. 11. And this is the mixed number you wanted to write, yes? Yes? All right, so screw that. You can just put it directly like that. No problem. So, of course, what's this dude?
562.
I love it. Get out of there. Get out of there. All right. And now, this isn't decimal addition, right? This is just, are they like denominators?
Yeah.
Yeah. So now it's just going to be whatever the hell, 1129 plus 562.
91.
And haven't they done that before?
Hopefully.
Hopefully, at this point, yeah. So this problem, you understand, we know the way the decimals work. This problem isn't really hard because they have the same number of decimal places, and that's the key thing, is to line it up correctly, all that kind of shit, right? But again, decimals are going to be like entirely new things. And you're just trying to make the connection to show them, no, there really aren't. Okay, maybe. And then whatever that is. What do you guys get? Is it
1691.
91, okay. Neato. And then put that back into decimal. 16.91. Yeah, 16.91. Chapeau. Now, of course, what way would we do that if we had to do this by hand?
Up and down.
Just flipping. Okay, I love it. Just put them in, and what would you line up?
The decimal.
Decimal place. Now let's talk a little more about that. So what about, yeah, this dude. I like it. So write those both as fractions. So what happens here? What do you get here?
1,000 and 100. I mean 10.
Tens. And of course, can you add those together?
No.
Not yet.
And at this point, they're just learning decimals, but they have learned fractions and like denominators and all that kind of stuff, right? So now it's become just a fraction problem where they need like denominators, and this kicks ass because these work really well together. What does this guy do?
2 zeros.
Yeah, so I gotta multiply him by 100. So then I get 3 over 1,000 plus 14700 over 1,000. And as you're doing this, can you make a connection to the way you would have done it, right? We wouldn't have done all this. But you can see the connection being made here, hopefully, right?
Mm-hmm.
Isn't this saying, all right, let's just get it's 14,703 over 1,000, which is?
14.703.
Okay, 14.703. Okay. So, real quick, if you do, well, let me even do it like this just so it looks weirder. Let's see. You would want to add a couple zeros. Maybe you don't really have to, but it's nice to because you have to do that when you subtract, so you might as well get them used to that, right?
Mm-hmm.
So the reason that I can keep adding zeros is because I can just multiply top and bottom by however many times I want to, right? And if they have the same number of decimal places, they automatically line themselves up. So this captures that process. So the next thing you would do after they get this is you would then say, oh, it's the same as doing this. So what are you always doing when you're trying to build math understanding? You get them to understand an idea, you move to a new thing and you make a connection with something they already have done, right? Okay, maybe. Okay. And then subtraction is the same thing, right? Now subtraction is even more interesting here, of course, right? So let's do one like that. All right, you got right. Subtraction. Let's see. You can do it, Jeff. What about 3.7 minus 1.49? I like it. So if you make this into fractions, what do you get?
37 over 10.
10. I like it.
49 over
100.
Good. And of course, to make them like denominators,
37 over 10 by 10.
you multiply by 10. So you get 370 over 100 minus 149 over 100. So now you got whole number subtraction, which they really know.
In fraction form, 221 over 100.
So 221 over 100, which will be 2.21. Now, what would it look like just straight up doing it, not turning it to fractions? You would line up the decimal places, right? Now, can you tell me real quick, what is that lining up the decimal places doing?
Making sure it stays in the same place. I don't know.
Why couldn't I combine what this was originally? Because they're not like terms, right? They're not, right?
Oh, yeah.
Anything after the decimal is tenths. So if I line up the decimals, the tenths are lined up, the hundredths are lined up, the singles are lined up, yes? the ones place. Are you guys you understand what I'm saying? So if you
Yes.
make the decimal the right place, everything is now lined up with its like terms. I can add 3/10 and 7/10 or subtract or whatever, right? Now, what we did here mimics exactly what we do there. We had a 0, so we got something to borrow from, right? Not just like an empty void. So we want a number there we can mess with. And then we can do, we borrow 1, blah, and then you get this. Okay, all right. Boy, it's probably good I don't actually teach it. And then you just do this shit. Oh, man. That'd be funny if I'm like that and all the kids are like, we love you. Yeah, whatever. All right. So that's kind of nice. In fact, I mean, we don't get to see this very much, or at least we don't remember when it was taught to us, if it was taught to us like this. But if you really kind of, and I know that you guys, most of you have told me very publicly that you don't like fractions, right? You were like, where's he going with this? You don't like fractions. I understand. In fact, most people just don't. And that just tells you that if you're going to teach students fractions for the first time, you're going to have a lot of responsibility on your shoulders, because that's where they start to lose it. If they're first person, right? And again, you understand what I'm saying?
That's wrong.
This is one reason why you should want to do this job, is because you understand it's a big responsibility. You want to be there to do it. You want to do this. That's huge, because the early math they get kind of tells you what direction they're going to go. It really does. And of course, also the big thing, of course, is when parents are like, I was never good at math. It's okay if you don't know. And then they're like, well, then I don't have a chance, because they think that means the math wasn't passed to them. Do you guys understand? So it's partially you, partially parents, of course, blah, blah, blah. Now, okay, so nothing too much about subtraction there. It's basically the same idea as addition. What do you think you would say to a student who said something like, multiplying always makes things bigger? What do you think you would say to that? Does that sort of make sense on the surface of it?
Yeah.
Multiplying always makes things bigger? Only when they're whole numbers? So 11/9 times 7/3. Those are both whole positive. I mean, those are both. All right. So you're saying that multiplication only makes it bigger if they're both positive whole numbers, right? But 11/9 times 7/3 will be bigger than either one of those. So here's the real thing. If you multiply two numbers greater or equal to 1, or let me just say greater than 1, they'll be bigger, right? If you multiply them less than 1, they get smaller. I like it. And what the hell? What does that mean? Well, what's 1/2 times 1/2? What happened? Okay, 1/4, right? Half of a half is a quarter. Yes? Okay. And again, it's because fractions are inverses of whole numbers. So when that's true, right? So if I have a fraction that's bigger than 1, and another fraction that's bigger than 1, tell me out here. How do I do this? They're both bigger than 1. You guys agree?
Yeah.
Okay, because they're both top heavy. They're both improper. What can I do real quick to make this a little easier?
9 times 4.
Oh, common.
Cancel some shit, right?
Oh, hello.
Hello. And so a 3 goes in, a 3 goes in, right?
Yeah.
And you get 44 over 15, yes? Somebody help me out. What is 11 divided by 9? Somebody help me out. What's 11 divided by 9?
Like decimal?
Yeah.
Oh, okay. 1.22.
Yes, 1.22222. Woo! And this one, what's 12 divided by 5?
2.4.
2.4. And what is 44 divided by 15?
2.93.
So the result was bigger than either one of the parts. So when you're multiplying numbers, that are less than 1, the result will get even smaller, right? And when you multiply numbers bigger than 1, the result gets bigger. So when you get into decimals, you kind of have to adjust the students' kind of assumptions, because everything they've seen so far before fractions and decimals are whole numbers. So 2 times 7 is 14. That's bigger than 2 or 7, right? So you gotta go, well, that's because before we were using things that were bigger than 1 for the most part. Okay, so that's one little side note. Okay, so what about this? Let's go to multiplication. So what do I got? Let's do one, yeah. Let's make it a little bit less crazy, Jeff, yeah. All right. So how do you think I'm gonna attack this first? What do you think I'm gonna do, being the weirdo that I am?
Fractions?
Fractions, there we go. So what is, what's 4.3?
43 over 10.
43 over 10.
305 over
100, I like it. All right, so what do you get on the bottom?
$10,000. 1,000.
So you have this 100, and then one more 0. You see? Bam! You just count all the zeros. There's 3 zeros between these, so there's 3 zeros in the answer. And on the top, you get whatever the hell that is. Somebody help me out. What is it?
13,115.
Say again, start.
13,115.
13,115. So of course, what is that as a decimal then? 1, 2, 3. 1, 2, 3. I like it. So, the thing to notice, when you make it into fractions, you look at it as if it's just 43 times 305, right? And kind of the last thing that we did, are you guys with?
Yeah.
Okay, so we changed it to fractions, the bottom was its own thing, and the top is really what I'm focused on at first, correct? And I know you guys remember this. And the last thing I worry about is how much to move the decimal. So this is this. Get out of there, an extra one. There we go. Right, that is this, yes? And the last thing I had to worry about was where to put the decimal spot. Do you guys remember this reality? Yes? So for example, if I do something a little bit less crazy, 1.4 times 0.7. Okay. Help me do this. So what would you do just to do it? Do it. Yes? So what do I put here? I put 8. Put a 2 there.
7 plus 2.
9. That's not the answer though, right?
9.
Yeah, this is, listen. This would be this tenths, yes? This would be this tenths. Tenths times tenths is hundredths. So the shortcut is 1, 2, move it back twice, bam.
So when you're multiplying fractions, I mean,
Decimals.
you move the thingy.
The total number of places that you see, because that corresponds to, this is 1 place, this is 2 places, yes? And that's why the end, I did 3 places. 1 place, 2 places, the end was 3 places, because 10 times 100 is 1,000, 3 zeros. So that's why you do that, moving it back to total number of spaces you see. Yes? Mm-hmm. Yes?
Did we do the division before?
Have we done a division before?
Well, like, have we done it when I was in the bathroom? Did you guys do it?
No.
Oh, okay.
Yeah, we like to go add, subtract, multiply, divide. So we finished add, subtract. We're now doing multiply. Let me see. Do I want to do? Yeah, we could do. Yeah, there it is. Too bad for you. Oh, can you guys please do this problem without a calculator?
Oh, okay.
All right, let's see. That's not gross enough. I'm joking. there we go. All right. All right, now let me stop you. What's the first thing what's the first thing?
Get rid of the decimals.
Yeah, how do you do that? What do you do? What's the very first thing you do once you've written this down? What's the very first thing you do?
Put the decimal up.
Move the decimal, yes? What do you mean? Oh, I see what you mean. Careful. No, let's see. Do you guys remember? Has it been too long since you did
a
long?
whole number.
Yeah, don't I have to move this over?
Yeah,
I move that over.
yeah,
Do you remember that?
yeah.
Nope.
Shit.
Well, I do, but.
Alright.
No, now I know.
Yeah. You guys don't remember? It's been a while, maybe, since you've done long division.
Oh, yeah.
Yeah. Me, I'm old, but I mean, I've taught shit like this, so it's not been as long as for me. But if it's been a long time since you did a long division of decimals, which I'm almost certain it has been, you might forget this, but some of you guys remember this, yes?
Yeah.
Okay. And then, I mean, just to finish this up, so now I've got 12 into 493.2. 448 minus equals 31, 12 minus equals 12. And then, like, I think May, you just said this, right?
Yeah.
With the decimal there,
Mm-hmm.
and then 12 goes into 12 once. Yay! Now, why the shit are we allowed to just go in there and move stuff around?
Because the fractions have something to do with this.
No way. All right. So, what is this in fractional form, of course? Because this is just a way to rewrite a fraction, yes?
Mm-hmm.
What fraction did that used to be?
What, 1.2? Wait, what?
What fraction? All right, listen. Make this into a long division problem.
7 divided by 8.
Yes, 7 divided by 8. Yes?
Yeah.
All right, now forget about it. Now, what must this have been then? Hmm?
49.32
Divided by 1.2. Yeah. Put it back to normal. There we go. Yes? And can't I just multiply top and bottom by anything I want to? Except 0, right? So could I just multiply top and bottom by 10? Because I want a whole number here. That's the whole reason we do it. But why are we allowed to do it? Because it really is just this. That's why whatever number of places I have to move it to make this a whole number, I move this one the exact same number of places, that's equivalent to multiplying top and bottom by the same thing, which I am allowed to do whenever I want to. Okay. I like it. Now, even another way to look at this. If I have 49.32 divided by 1.2, here's the ultimate initial thing you can do. Same thing we've been doing, right? Same thing we've been doing, right? As a fraction immediately. What is this?
29.32 over 100.
All right, I like it. And then this, of course, is? And what do they know? They know fractions, so they know when you divide a fraction, you... What do I remember? Okay. Come with 3. And of course, what happens here?
Multiply it.
Right?
Wait, we're not. Oh.
Now, real quick, let's look where we are. 49.32 divided by 10, isn't that this? And then I got the 12 on the bottom, so I'm dividing by 12, isn't that there? Right? Okay, maybe. So now it's just become, this now, right? So now you can focus on what is this divided by this, and then you move the decimal back once. That's a way to look at the fractions. But really, this is exactly what I've got here at the moment, right? Okay, maybe. So there's a few different ways you can kind of look at why that decimal motion is allowed. Okay, I like it. Oh, okay. And again, every operation, we're taking it back to fractions because they just work the shit out of fractions, yes? So they're all about fractions. So the more you can relate it back to that, the more connections they can make. So you do this, you connect it to this, and now they've got the shortcut kind of algorithm. Okay. We talked about this next thing earlier, but just to really come back to it. Scientific notation. This will be the last thing we'll talk about, okay? We talked about this a little bit. I can't remember where it came up before, but for example, let's do this first. 4,000. Can somebody write that as 4 times something? 4 times that. Holy shit. So 4,000 is 4 times 1,000, and then 1,000 is how many tens?
2.
3.
10 times 10 is 100.
3.
3. How many zeros? 3. So scientific notation is not just like a way to write a number. It's actually a little problem that works out to the number. One thing the book doesn't talk about yet, but I'm going to talk about real briefly. The book doesn't talk about this because we haven't officially introduced negative numbers yet, right? But what is that as a fraction? 4 over 1,000. And 1,000 is 10 cubed, yes? And does somebody remember?
Oh, no.
All right. You both knew what I was going to say and also knew you didn't remember. I love that. What makes something flip? What kind of power makes something flip? Did we talk about this? Yeah, I think you're making the sign for negative. So this would be 4 times 10 to the negative 3. 10 to the negative 3 would flip underneath. So a negative power really means you're dividing by that, which totally makes sense. If I have a scientific notation with a negative power, it must have been a small-ass number because I'm dividing by a bunch of tens. If I have a scientific notation with a positive exponent, it's got to be a big-ass number because I'm multiplying by so many tens. So what's the shortcut? Where's the decimal in this number? Where's it understood to be?
Add that last 0.
Yeah. How many times I have to move it until it gets behind one digit? 3 times.
3.
That's why there's a 3 there. Same thing here. How many times do I move this until it's after one digit? 1, 2, 3. That's why that's a 3. Why is it negative? Because that's small. Maybe. And again, I don't know if I told you this, but I'm bad with left and right. So when I was taught scientific notation, they said, when you move it to the left, you do this. I'm like, holy shit.
Use arrows.
So I'm like, if it's big, it's positive. If it's small, it's negative power, right? That makes a lot more immediate sense, to be honest. Okay, all right. I once again made some of you depressed, and I'm so sorry. I don't know. It's the last thing I ever want to do. But that's it. We'll stop there. I'll have the quizzes graded next time. And let me know if you have any questions. Yeah. Oh yeah, so the shortcut with
So the GCF was just finding like the lowest one?
yes, and then the